Hello everyone. In this presentation, we will talk about Android weather application and how it is built. First, we will discuss what Android Studio is, some features of the Android Studio, and how it works. What is Android Studio? Android Studio is a tool that makes developing an Android application much easier. Android Studio is an IDE, known as Integrated Development Environment, because it integrates multiple development tools together. It is combined with a robust code editor with an entirely new build system based on Gradle. Android Studio checks for errors in our code as we type and also gives a suggestion to code faster. As we create our app, we want to see an action. Android Studio builds and runs application actually on an Android device or an emulator, a tool that allows our computer to simulate an Android device. Here are some features of Android Studio. Powerful code editing, like it gives us suggestion to code faster. A flexible Gradle-based build system to automate and manage the build process. A rich layout editor that allows the user to drag and drop UI components. Option to preview layouts on multiple screen configurations. Template-based wizards to create common Android design and components. Its code templates and GitHub integration to help us build common app features and import code. It provides a unified environment where we can build apps for Android phones, tablets, Android Wear, Android TV, Android Auto, etc. Now we will see what an emulator is. Android emulator is a software which can emulate or run an Android operating system in a desktop or laptop for the users who want to develop or for Android use. Android emulator is typically used for deploying applications that are developed in an IDE without actually installing it in a device. Android emulators such as BlueStack can run Android apps, wherein emulators like AVD and Genymotions are used to emulate an entire operating system. Additionally, these applications work the same way on PCs as they do on the mobile phone. Best emulators for the Windows PCs and Mac OS laptops are BlueStacks, LD Player, GameLoop, Andy, Mamu, Prime OS, Genymotion. What is Gradle-based build system? The Android build system compiles app resources and source code and packages them into APKs that can be tested, deployed, signed, and distributed. Android Studio uses Gradle, an advanced build toolkit, to automate and manage the build process, while allowing you to define flexible custom build configurations. We can use features of the build system to do following. Number 1 is customize, configure, and extend the build process. 2. Create multiple APKs for applications with different features using same project and modules. 3. Reuse code and resources across source sets. Android Studio build files are also named as build.gradle.
Any application has and should have a user interface that is everything that the user can see and interact with. Android basically provides a variety of pre-built UI components such as structured layout objects and UI controls that allow us to build a GUI that has a graphical user interface for an application. Android also provides other UI modules for special interfaces such as dialogues and notification menus. The typical UI components that are used for any Android application development are namely main action bar, view control, content area, and split action bar. These play a major role in developing a complex application. Another important factor that helps in customizing the UI design is the view component. The view is the component which Android provides us to design the layouts of the app. So we can understand view as a rectangular area which is going to contain some elements inside it. A view is a superclass for all UI components. Below are some of the view components. Text view. This is used to add text in our application. Edit text. This is used when we want to take some input from the users. Image view is used to add images in the application. Progress bar is used to show the progress of something, for example, the loading screen. Button. Buttons are used to trigger some action on the click of the button. It can be starting a new activity or something else. Image button. It is used to make a clickable image. Checkbox. Checkbox is used to select some options out of many available options. A group of view is known as view group. The top level view group is a parent, and under it all the view and other view groups are its children. For example, under a linear layout, we can add two buttons and one edit text. Here, linear layout is the parent view and the button and edit text are the children. A layout defines the structure for a user interface in an app, such as in an activity. All elements in the layout are built using a hierarchy of view and view group objects. A layout can be declared in two ways. First, it can be declared using UI elements in XML. Second, it can be declared by instantiating layout elements at runtime. Another method of creating layout in Android Studio's layout editor that can be used to build the XML layout using a drag-drop interface. The layout editor enables us to quickly build layouts by dragging UI elements into a visual design editor instead of writing layout XML by hand. The design editor can preview your layouts on different Android devices and versions, and we can dynamically resize the layout to be sure it works well on different screen sizes. The layout editor is especially powerful when building a layout with constraint layout, a layout manager that's compatible with Android 2.3 API level 9 and higher. In this figure, we can see the layout editor and marked by its important features. First is palette. It contains various views and view groups that we can drag into our layout. The second is component tree. It shows the hierarchy of components in our layout. Third is toolbar. We click these buttons to configure our layout appearance in the editor and change layout attributes. Four is design editor. We use it to edit our layout in design view, blueprint view, or both. Fifth is attributes. These are the controls for the selected view's attributes. Sixth is the view mode. This is used to view your layout in either code, design, or split modes. Split mode shows both the code and design windows at the same time. And lastly, 7 is the zoom and pan controls, as it controls the preview size and position within the editor. We can open an XML layout file. The design editor opens by default as shown.
For a weather application, we decided to use OpenWeather and their API platform. OpenWeather API has been around since 2014 and has a devoted team of IT experts and data scientists that have been continually working in weather data science. Their API platform allows for historical, current, and forecasted weather conditions with access to over 200,000 cities. They collect from many different sources, including local weather models, satellites, radars, and a vast network of weather stations. On top of this, they offer the necessary requirements we needed to complete our weather application. So we use the free version, which has a good amount of functionality and allows us to pull data in JSON, XML, and HTML format. The API allows you to make calls based on what your needs are, including city name, zip code, geographical coordinates, as well as several cities within a certain area, and so on. For the purposes of our application, we needed to make an API call based on physical coordinates and city name. For the geographical coordinates, we needed to establish a couple parameters to make the API call. So this here is what is needed by OpenWeather to create the API call. The three most important parameters that need to be established is latitude, longitude, and the app ID, which is essentially the API key. Latitude and longitude will be provided by the device's geographic coordinates and will be used to access the weather accordingly, while the app ID, as I mentioned before, which is the API key, is given and will allow you to access the weather services of the API. For calling weather location based on city names, we would replace the latitude and longitude with a parameter called Q. Q would require the city name, state code, county code, and they're all divided by a comma. But since we're using the freemium version of the API, we're only allowed a certain calls per hour. This is why it's important to make sure our app ID is only being used by our application, so we don't have to worry about going over the amount of API calls that are given. If we were to further develop and publish our application, we would need to use the paid subscription version, and this will allow us to have unlimited amount of API calls. So a big part of our application is by using the location of the Android device to determine the coordinates of the API. So one of the first things we have to establish is how to get permission from the device to access the location data. To do this, we allow the app to access the find location and course location in the Android manifest file. We then incorporate these parameters into our main activity file with on-permissions checks functionality. In this function, we are given a list of permissions that are granted. If all the permissions are granted, the location data is then requested. If any permission is denied, we notify the user that you have been denied location permission, please enable. Another function is location enabled. In this function, we determine if the location provider is turned on and prompt the user to enable accordingly. This function also determines the location if it's from the phone's GPS or network provider. It doesn't have to do with the device permissions, instead deals with system settings that are needed for the application to work. Once all permissions are granted and all system settings are enabled, we could then go about finding the physical location of the device. To do this, we created a function named request location data, which will allow the application to access the device's individual latitude and longitude data points. Once we have those data points, we can store them in lat and long variables to be used in our API call. These steps, along with our API key, will be used to initiate the JSON pull from the API. This will allow us to display the weather information needed based on the device's physical location. And as shown, the top kind of shows how in the Android manifest file we request for certain permissions for the find location and course location. And then also this is just a short piece showing how our is location enabled function works. So lastly is the API call itself. Once we've entered the information on the device, we can initiate our JSON call from OpenWeather. As mentioned before, we need to establish the three parameters, lat, long, and app ID within the constants Kotlin file. In this file, we establish pretty much everything that's going to be used in constructing the poll URL. The format is essentially the URL of the device and inputting the latitude and longitude, and then also putting in the API key at the end. We then use retrofit to construct the URL within a weather services Kotlin file that combines all the variables into the URL for the poll. Once the application is started or refreshed, the JSON poll is initialized from the constructed call. Once we receive the JSON information from the calls, a function called getLocationWeatherDetails is then used in the main activity Kotlin file that will receive the information from the API call. Then within the main activity file, a JSON converter factory is used to convert all the JSON information into a JSON format. The first picture here shows what API, all the information that is pulled from the API poll. The JSON format is then used on all the data that's used and processed within any other functions throughout the application. Information is then stored into individual variables within the weather response Kotlin file. These contain variables such as coordinate, weather, base, main, visibility, wind, clouds, DT, system, ID, name, and COD. We determine these by using a JSON viewer to parse a sample JSON poll and essentially organize them into logical subcategories. As you can see, this in the first picture is the base API data, and the second is the JSON viewer that kind of organizes everything into a logical format. By doing this, we then proceed to create individual Kotlin files for clouds, cord, sys, weather, wind, and main in accordance with that JSON view picture. And they will process all the information that was received from the variables in the weather response file. We can then go about dictating the information that is stored, and eventually these files will display the information on the actual UI itself.
Git is the version control manager that we used for our project. Git is a version control manager we used to manage our Kotlin codebase. Essentially, it creates a filing system on a local machine that can then be replicated on a shared online GitHub repository. It also provides a wide variety of utilities that are of use to multi-developer teams. In particular, the Git Bash command line client is the most useful. The Git manager permits multiple users to append to a central repository. In this graphic, we have 2 developers contributing to a central repository or codebase. Each user has their own files and are permitted to append to the codebase as they see fit. Each of the team members for our project had the Git enabled on their system. We each contributed to the codebase via 2 key commands, git push and git pull. The git push command pushed file changes onto the repository, while the git pull command allowed us to pull files from the GitHub website on which our code was stored for easy referencing. Git bash is the command shell that permits users to maintain and migrate files found locally on their system onto the GitHub repository. The Git bash client permits users to enter a variety of commands to create, modify, and append to an existing project. For our project, we made use of the 3 following commands. 1, git push -u origin master, to initiate publishing of files to the file system and logging onto GitHub. 2, git add -a, formally adding the files onto the Git repository. 3, git push, final command for publication of files to our team repository. GitHub is the online landing page for referencing shared code amongst a team of developers. We developed the application collaboratively using the landing page to look at specific files for reference. In addition to that helpful use, it also permits us to enforce privacy settings so that our code base is only accessible to team members. And it also lists all of the files that make up the project. It also includes helpful modules for pull requests and defect management. We forked our project to permit a locator branch that would implement a locator function to adjust location changes as per the user need. We modified our code base on the locator branch while leaving the main code unchanged. This enforced a lot of version controlling, which was helpful for when we refactored our code at a later point during our development process. The actual technical walkthrough of what our app actually does and how it operates. At its core, we used the Kotlin language for the mobile app development because we wanted to create an Android application. Kotlin is the dominant language used for Android app development, and it is also very similar to Java in that it is an object-oriented programming language. When developing the application, we also had to be mindful of the Gradle file. It is a file that is responsible for providing the base framework for the Android application. References certain software packages that a developer may use to implement certain functionalities unique to the software package. In our instance, we also specify the Open Weather API for its ability to reference real-time weather data in this particular file. The Android manifest file is also really critical to understand how the app itself operates. It is a mandatory file that specifies information regarding the operating system, application build tools, and interoperability with Android systems. It specifies the package name linked with the code space. It establishes the services the application will reference, and it also seeks permissions that the application needs to run. In our instance, we reference style attributes referenced in the style.xml file. We also had a constants file as part of our project. It specifies the unit of measurement that we wish to display the temperature in degrees Fahrenheit. It also permitted interoperability with both desktop and mobile environments. It was in this file that we also specified our unique key to access the Open Weather API when running our weather application. We also had the main.kt file, which created variables to display on the actual app display. These were temperature, pressure, humidity, the minimum temperature and the maximum temperature for daily use considerations, the sea level and ground level. We also had the main activity.kt file. This was the master file that is the executable that implements the files discussed and additional view models from supporting XML documents. It checks for permissions at the device level and displays error messages when those permissions are not granted. Upon granting of permissions from the device, it seeks latitude, longitude, units of measurement, and time zone considerations of the user and their device. Then we have to look at the actual app itself. The app display showcases the following information for a particular city: cloud conditions, current temperature with humidity, daily maximum temperature, wind speed, locality, and sunrise and sunset times. We also had to make use of the phone system settings to modify the location and its corresponding data. We were able to choose cities from different continents and reflect weather location in real time. The weather app application had to be refreshed to view the updated information.